Assalamu alaikum. Today we are going to see the topic Fourier half range series. Before starting this is my YouTube channel Explore Maths with Abdul Azim Sir. Like, share, comment and subscribe to my channel. Now let us begin the topic. Fourier half range series. So we have half range sine series and half range cosine series. What do you mean by half range? So the interval will be 0 to pi only. In previous chapter half Fourier series the interval will be minus pi to pi and here 0 to pi. That's all. So this is the difference. So write the half range sine series of f of x in the interval 0 to pi. So the half range sine series is f of x sigma n is equal to 1 to infinity bn sine nx. So where bn is equal to 2 by pi integration 0 to pi f of x sine nx dx. Now half range cosine series is f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity an cos nx, where an is equal to 2 by pi integration 0 to pi f of x dx, and this an value is 2 by pi integration 0 to pi f of x cos nx dx. So these are the two definition it will may ask in the exam. Now first question, represent the function f of x is equal to k, that is constant, by a Fourier sine series in the interval 0 less than x less than pi, that is interval 0 to pi. F of x is given k. Fourier sine series, that is f of x is equal to sigma n is equal to 1 to infinity bn sine nx. So we have to find this bn. So bn formula is 2 by pi integration 0 to pi f of x sine nx. So 2 by pi outside as it is. What is f of x? K into sine nx dx. This is constant, take outside. So 2k pi by pi outside integration sine nx minus cos nx by n 0 to pi. Now minus take outside, so minus 2k by pi and n outside, so n pi. Now upper limit cos n pi minus cos n 0, cos n value minus 1 power of n minus n into 0 0 cos 0 1. Now this multiply minus into minus plus 1 minus into plus minus. Since we have n, so here we have two cases. If n is odd, suppose if I take n is equal to 1, so minus 1 power of minus 1 minus into minus plus, so 1 plus 1 2, so 2 into 2 4k by n pi when n is odd. If n is even, suppose here 2, so minus 1 power of 2 plus 1, 1 minus 1 0, 0 into something 0. So we have only 4k by n pi value when n is odd. Substitute in 1. This one sigma n is equal to 1 to infinity an, bn. Bn means 4k by n pi sine nx. So 4k by pi constant outside 1 by n sine nx. Now apply sigma. So 1 by 1 sine 1x plus 1 by 3 sine 3x plus 1 by 5 sine 5x. 1 by 1 1. 4k by pi outside as it is sine 1x plus 1 by 3 sine 3x plus 1 by 5 sine 5x. Now next question. Find a naught in the half range cosine series of f of x pi minus x in 0 to pi. So f of x pi minus x in 0 to pi. A naught, since it is a naught value is 2 by pi integration 0 to pi f of x dx. So what is f of x? Pi minus x dx. Now pi as it is, what is integration of 1 x minus integration of 1 plus 1 by 1 plus 1, that is x square by 2. Now upper limit minus lower limit, pi as it is. For this x, pi minus 0. For x square by 2, pi square by 2 minus z square by 2. Pi into pi, pi square minus pi square by 2 minus 0 means pi square by 2 only. Cross multiply 2 into pi square, 2 pi square minus pi square by 2. So this value is become pi square only by 2. These two cancel, pi and here 1 pi. So answer is pi. A naught value is pi only. Next question, find the value of b1 for the function f of x is equal to 1, which is expanded as the sine series in the interval 0 to pi. Given f of x, this one, we know the formula of bn, 2 by pi integration from 0 to pi f of x sine nx dx. So 2 by pi outside as it is f of x. What is f of x? 1 sine n. Since b1, substitute n is equal to 1. Here n is equal to 1. So integration sine x minus cos x. So take this minus outside. So minus 2 by pi outside. Upper limit cos pi minus cos 0. What is cos pi? Minus 1. Minus as it is cos 0, 1. Minus 1 of minus 1, minus 2. Minus 2 into minus 2 plus 4 by pi. So bn value is 4 by pi. Next question, find the value of a naught in the half range cosine series f of x is equal to e power of minus x in 0 to pi. Now f of x, this one, a naught value 2 by pi integration 0 to pi f of x dx. What is f of x? E power of minus x. So integration of e power of minus x, e power of minus x by minus 1. So this minus, if you take outside, it become minus 2 by pi e power of minus x as it is. Now upper limit minus lower limit, e power of minus pi minus e power of 0. So minus 2 by pi outside as it is, e power of minus pi as it is, minus anything power of 0, 1. So this is a naught. Next question, this is very important for the examination point of view. Find the half range cosine series for the function f of x is equal to x square in the interval 0 to pi, and hence find the sum of the series 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square up to 0, up to so on. Now let us go. So f of x given in the interval 0 to pi. So what is formula? F of x is equal to x square is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx. First equation. First we will find a naught, then a n. A n formula is 2 by pi integration 0 to pi f of x dx. What is f of x? X square dx. X square integration x power of 3 by 3. Now upper limit 2 by pi outside as it is, pi cube by 3 minus 0 cube by 3. So 2 by pi outside as it is, pi cube by 3. This 1 pi and 1 pi cancel, 2 pi square by 3. A naught value is 2 pi square by 3. Now an formula is 2 by pi integration 0 to pi f of x cos nx dx. What is f of x? X square cos nx as it is. See here, since multiplication is there, so we will use Bernoulli's rule. So what is Bernoulli's rule? Now here this is u, that is x square. So x square as it is minus derivative of x square 2x, derivative of 2x 2, here plus 2. Now integration cosine x sine nx by n, sine nx by n integration minus cos nx by n square, and this integration minus sine nx by n power of 3 between 0 to pi. Now upper limit minus lower limit for these three terms separately. For here pi square sine n pi by n minus 0 square sine n 0 by n, minus into minus plus 2 by n square. Here x cos nx pi cos n pi by n square minus 0 into cos n into 0 by n square, minus plus minus 2 by n cube sine n pi minus sine n 0. Since all sine values will be 0, so this 0, this 0. 2 by n square pi, what is cos n pi value? Minus 1 power of n by n square, minus 0 into something 0, so all value will be 0. Sine value 0, sine value 0. So 2 by pi outside as it is pi minus 1 power of n by n square. This pi cancel, 2 2s are 4, minus 1 power of n by n square. So this a naught, this a n, substitute the value in first equation. So our first equation x square by x square is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx. So what is a naught value? 2 pi square by 3 by 2 plus sigma n is equal to 1 to infinity a n. A n value is 4 into minus 1 power of n by n square cos nx. See here it is plus and here n. I am writing minus here and this is n plus 1. 4 by 4 outside as it is. Now expand this. X square is equal to pi square by 3 minus 4 minus 1 power of 1 plus 1 by 1 square cos 1x plus minus 1 power of 2 plus 1 by 2 square cos 2x plus minus 1 power of 3 plus 1 by 3 square cos 3x plus minus 1 power of 4 plus 1 by 4 square cos 4x up to so on. Now x square is equal to pi square by 3 minus 4 into this one become positive 1 by 1 square cos 1x, 2 plus 1 3, so it become minus, so minus 1 by 2 square cos 3x, 3 plus 1 4, so minus become plus, so 1 by 3 square cos 3x, 4 plus 1 5, so it become minus 1 by 4 square cos 4x. Mark it as second equation. Now for deduction part, wherever x is there, put x is equal to 0. Here 0 square is equal to pi square by 3 minus 4, 1 by 1 square cos 0, 2 into 0, 3 into 0, 4 into 0. 0 square 0, pi square by 3 minus 4 cos 0 1, 1, 1, 1. So 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square. See this is minus, send it there, it become plus 4 into this series. Now 4 in multiplication, set it there, it become multiply, divide, 4 3s are 12. So the series is pi square by 12, proved. Now next question. Obtain half range series for the function f of x is equal to e power of x in 0 to pi. Since sine series there, we have formula sigma n is equal to 1 to infinity bn sine nx dx. So first we will find bn. So bn formula is 2 by pi integration 0 to pi f of x sine nx dx. What is f of x? E power of x. Since e power of x sine nx, we have a formula integration e power of x sine bx that is e power of x by a square plus b square, a sine bx minus b cos bx. See here, a means 1, b means n. Substitute here. So this 2 by pi outside as it is, e power of x as it is, by a square plus b square, 1 square plus n square, a sine bx, 1 sine nx minus n cos nx formula. So 2 by pi e power of x, 1 square 1 plus n square, 1 into sin x minus n into cos nx as it is. Now what we have to do, upper limit minus lower limit. So e power of pi 1 by 1 plus n square sin n pi minus n into cos n pi, upper limit, minus lower limit e power of 0 by 1 square plus n square sin n 0 minus n into cos n 0. Now this 2 by pi outside as it is, e power of I 1 plus n square sin n pi 0, and what is cos n value, minus 1 power of n, minus anything power of 0 1 by 1 plus n square, sin value 0 minus n into cos 0 1. So 2 by pi outside as it is, e power of pi 1 by 1 plus n square minus, so n, see here it is minus and n. So I am using this n into minus 1 power of n plus 1. So minus will come here. So it becomes minus 1 power of n plus 1. And this into 0, 0, minus into minus plus n by 1 plus n square. So 2 by pi, this is 1 by 1 plus n square, 1 plus n square denominator common. So this one n here and this value is here. So take out n by 1 plus n square common, n, so take out common 1 plus n square. So 2 n pi into 1 plus n square common. So this 1 plus e power of pi minus 1 power of n plus 1. This is our bn value. Substitute in first equation. So e power of x is equal to sigma n is equal to 1 to infinity bn sin nx. So what is our bn value? This one, 2 by n pi into 1 plus n square sin nx, and this one. So this is our value. Now expand this, 2 by pi outside as it is, 1 by 1 plus 1 square, 1 plus e power of pi minus 1 power of 1 plus 1 into sin 1x plus, now substitute 2 by 1 plus 2 square, 1 plus e power of pi minus 1 power of 2 plus 1 into sin 2x plus 3 by 1 plus 3 square, 1 plus e power of pi minus 1 power of 3 plus 1 into sin 3x up to so on. Now simplification, 2 by pi, so this is 1 minus 1 plus 1, 1 plus 1 2, so it become positive, 1 plus e pi, 1 plus e power of pi by 1 plus 1 square sin x plus 2 into this one minus, so it will come here, so 1 minus 1 as it is, minus, so minus e power of pi by 1 plus 2 square sin 2x plus 3 by 1 plus 3 square, 1 plus e power of pi sin 3x up to so on. Okay. Now next question, find the value of bn, okay, for the function f of x is equal to x, which is expanded as sine series. Okay, this one. So here f of x, the function f of x is equal to x is equal to sigma n is equal to 1 to infinity bn sine nx. So first we are going to find the value of bn. Okay, so bn is equal to 2 by pi integration 0 to pi f of x sine nx dx. What is our f of x? X sine nx. Now here we will use Bernoulli's theorem or Bernoulli's rule. What is this? X as it is minus derivative of x 1 sine nx integration minus cos nx by n integration of this minus cos nx integration sine nx by n square 0 to pi. Now apply limit for just minus x cos n pi minus into minus plus sine n pi by n square 0 to pi. Now upper limit minus lower limit minus pi cos n pi by n minus minus of 0 cos n 0 by n. Upper limit minus lower limit for this plus here sine n pi by n square minus sine n into 0 by n square. So this one minus pi as it is cos n pi minus 1 power of n by n 0 into something 0 plus sine value wherever sine is there 0 and this one 0. So this pi as it is this minus and minus 1 power of n it become minus 1 power of n plus 1 by n. This pi cancel 2 by n minus 1 power of n plus 1. This is our bn value. Substitute in first equation. So x is equal to sigma n is equal to 1 to infinity bn. Bn value is this one sine nx. So these two take outside sigma n is equal to 1 to infinity minus 1 power of n plus 1 by n sine nx. Now expand it wherever n is there 1 plus 1 by 1 sine 1x plus minus 1 power of 2 plus 1 by 2 sine 2x plus minus 1 power of 3 plus 1 by 3 sine 3x up to so on. So this 1 plus 1 2 so it become positive sine 1x 2 plus 1 3 so minus 1 power of 3 minus 1 by 2 sine 2x plus 3 plus 1 4 minus 1 power of 4 1 by 3 sine 3x up to so on. This is the answer. Now next question. Find Fourier cosine series. Cosine series for f of x is equal to x sine x 0 to pi. First question. Hence show that 1 plus 2 into 2 by 1.3 minus 2 by 3.5 plus 2 by 5.7 up to so on is equal to pi by 2. Okay. So f of x given. So Fourier half range cosine series f of x that is x sine x a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx. So first we will find a naught that is 2 by pi integration 0 to pi f of x dx. So what is f of x? X sine x. So using Bernoulli's rule, first u x as it is minus derivative of x 1 sine nx integration minus cos nx integration minus sine nx. Now upper limit minus lower limit. So minus x cos x minus into minus plus sine x. Now upper limit minus pi cos pi minus 0 cos 0 plus here sine pi minus sine 0 minus pi as it is cos pi minus 1 power of n minus 0 into something 0 plus sine 0, sine values all will be 0. So this one is minus into minus plus pi, pi cancel, 2 is the answer. Next an value is 2 by pi integration 0 to pi f of x cos n x. What is f of x? X sine x cos n x as it is. So as we have seen in trigonometry, this is sine x cos x. So these two I will take inside and 1 by pi outside as it is x. So these two when it come here, bring it here, so it become 2 sin x cos n x. This is cos n x. Okay, since we have know the formula 2 sin a cos b, sin sum minus sin difference, so it become x sin x plus nx, means n plus 1 into x minus n minus 1 into x dx. Now this is u, this is v. Apply Bernoulli's rule. This x as it is minus derivative of x 1. Now this one integration sin x integration minus cos n plus 1 x by n plus 1. Sin x integration minus into minus plus cos n minus 1 x by n minus 1. Okay, my again derivative of this minus cos n plus 1 integration minus sin n plus 1, n plus 1 become n plus 1 whole square. Here cos becomes sin n minus 1 x by n minus 1 whole square, 0 to pi limit. Now upper limit minus lower limit 1 by pi outside as it is. This x upper limit pi, okay, this minus as it is pi cos n plus 1 pi by n plus 1 plus cos n minus 1 pi by n minus 1 upper limit minus wherever sign is there 0, all are 0, and in here also 0. So final answer 1 by pi, this pi cancel, okay, and taking pi common, so this one cos pi cos 180, it become minus 1 power of n plus 1 by n plus 1 plus this one, it become minus 1 by n power of cos n minus 1, so minus 1 power of n plus 1 by n minus 1. Here minus 1 power of n plus 1 plus 1 take common. Here it is positive, so 1 by n minus 1. Here it is minus, so minus 1 by n plus 1. This outside as it is, cross multiply n plus 1 ones are n plus 1, n minus 1 here, so minus n plus 1, n minus 1 n plus 1, a plus b into a minus b, a square minus b square, n cancel, 1 plus 1 2, minus 1 power of n plus 1 by n square minus 1. This is an value is this one. See here, before this just we will find first value, put n is equal to 1 here. So this one x into 2 sin x cos nx. So here put n is equal to 1. So into 1 by pi integration x into 2 sin cos 1x. So here 2 sin a cos a, sin 2 theta formula. So sin 2x dx. Now for this it is uv, Bernoulli's rule, x as it is minus derivative of x 1. Now v, sin x integration cos 2x minus cos 2x by 2, integration again here minus sin 2x by 4, 0 to pi. Now upper limit minus lower limit 1 by pi, upper limit minus pi cos 2 pi by 2 minus here it is 0 plus sin value always 0 0. So 1 by pi minus 1 cos 2 pi 1 by 2 only. This pi cancel, minus 1 by 2 is the answer. Now we have seen, find that, substitute a naught, a1, an in first equation. So this one x sine x, a naught value is 2 by 2 minus this one minus 1 by 2 cos x plus 2 into sigma n is equal to 1 to infinity an value is minus 1 power of n plus 1 by n square minus 1 cos nx. So 2 by 2 cancel 1 minus 1 by 2 cos x, these two outside as it is. Now expansion, minus 1 power of 1 plus 1 by 1 square minus 1 plus cos 1x plus minus 1 power of 2 plus 1 by 2 square minus 1 cos 2x plus minus 1 power of 3 plus 1 by 3 square minus 1 cos 3x. All are same, but here minus 1 power of 1 plus 1 2. So 2 means positive cos. See here minus 1 power of cos x. Okay, so here downside 1 square 1 1 minus 1 0. So no solution. For this no answer. Here only 2 square minus 1. So that is a minus b into a plus b. 2 minus 1 into 2 plus 1 cos 2x. Same here 3 minus 1 by 3 plus 1 cos 3x up to so on. So for here put x is equal to pi by 2 in here. Pi by 2 sine pi by 2. Since sine 90 is 1, 1 minus 1 by 2 cos x means pi by 2, x means pi by 2, pi by 2, pi by 2. Pi by 2 sine 90 1, 1 by 2 this one, so cos 90 0, 2 cancel cos pi 1, 3 by 2 cos 3 by 2 0, 2 cancel cos 2 pi 1. So pi by 2 plus is equal to 1 minus, so take out minus common, 2 plus, so minus become 1 by 1 dot 3 plus become 1 by 3. Since here 0, so 1 3 3 5 5 7 up to so on. Send, so pi by 2 is equal to 1 plus 2 ones are 2 by 1 dot 3 minus 2 ones are 2 by 3 dot 5 plus 2 into 1 by 5 dot 7 up to so on. Okay. Now discontinuity question or piecewise. F of x is equal to x when 0 to pi by 2, pi minus x 1 pi by 2 to pi. First question. Show that f of x is equal to 4 by pi sin x minus 1 by 3 square sin 3x plus 1 by 5 square sin 5x. This is your piecewise question. Sine series, we know that f of x is equal to n sigma n is equal to 1 to infinity bn sin nx. Mark it as first equation where L is equal to pi. Bn value 2 by pi integration 0 to pi f of x sin nx. What is, see here, first 0 to pi. So we will split as 0 to pi by 2 f of x sin nx, sin x plus this pi by t to pi f of x sin nx. So 0 to pi by 2 limit f of x x, pi by 2 to pi f of x pi minus x sin nx dx. Now apply Bernoulli's rule or integration x as it is in minus integration derivative of 1 derivative of x 1. Now sin nx integration minus cos nx by n, again derivative of this minus sin nx by n square between limit 0 to pi by 2 plus pi minus x, this is u. Now minus of derivative of this pi derivative 0 minus x 1, this is v. So integration minus cos nx by n, derivative of this here, So minus cos nx sin nx by n into n square between pi by t to pi by 2 to pi. Now here apply limit. Minus x means minus pi by 2 cos n into pi by 2 by n. Minus lower limit minus 0 into cos n into 0 by n, plus this is upper limit lower limit finish. Now for this here, for sine value same upper limit minus lower limit here. Okay. Now for this upper limit, now apply limit pi minus pi cos n pi by n minus sine n pi by 2 n square. Okay. Here this value here minus lower limit pi minus pi by 2 sine, see this here upper limit here minus for this lower limit sine n pi by n square minus sine n pi by 2 by n square. Okay. So 2 by pi cos 90 0, this one 0, 0 into something 0. Okay. Here sine n pi by 2 by n square remain minus sine 0 0, 0 by something 0, cos n pi 0, pi minus pi 0, minus this one 0 minus sine n pi by 2 n square as it is. So 2 by pi, this sine n pi by 2 by n square minus into minus plus sine n pi by n square. So this is 2 times. So n square LCM 1 plus 1 2 sine n pi by 2. So these two multiply 2 2s are 4 by pi sine n pi by 2 by n square. Now here Bn value is 4 by pi n square sine n pi by 2. Now see here, if it is even b power of 0, so 4 by pi 0 square 0, so it may come 0 if Bn will be 0, that is b2 b4 b6 all will be 0 if it is n. Okay. Example, see if it is 2, 4 by pi into 2 square sine 2 into pi by 2, 2 to cancel sine pi 0, so it will be 0. Now Bn value will be 0 if n is even. Bn value is 4 pi by n square sine n pi by 2 if n is odd. Substitute in first equation. What is first Bn? Bn value is this one, 4 by n is phi n square sine n pi into sine nx. 4 by pi take outside. Since it is odd, sigma value will be 135 1 by n square sine n pi by 2 into sine x. Now apply limit. Expand this 1 by 1 square sine 1 into pi by 2 into sine 1x plus 1 by 3 square sine 3 into pi by 2 sine 3x 1 by 5 square sine 5 pi by 2 into sine 5x 4 by pi as it is sine 90 1 into sine x 1 by 3 square sine 3 pi by 2, that is minus 1 sine 3x plus 1 by 5 square, this one value is 1 sine 5x. Okay. So final answer 4 by pi sine x minus 1 by 3 square sine 3x plus 1 by 5 square sine 5x up to so on. Now next question. Represent f of x is equal to 1 by Fourier Sine series in the interval 0 to pi. Okay. Now see here, f of x is equal to 1. So what is f of x here? The sigma n is equal to 1 to infinity bn sine nx. First we will find bn. Bn formula is 2 by pi integration 0 to pi f of x dx. What is f of x? 1 into sine nx. Integration of sine nx minus cos nx by n 0 to pi. Now upper limit minus lower limit, take minus outside, minus 2 by pi cos n pi by n minus cos n0. Cos n pi, see here, minus 2 by pi cos n pi value is minus 1 power of n minus n into 0, 0 cos 0 value is 1. Open this, minus into minus plus, minus into plus, minus 1 power of. This is bn value. See here, when in n is odd, odd means suppose n is equal to 1, minus 1 become minus 1. So minus 1 is plus 1 plus 1 2, 2 2s are 4 by n pi when n is odd. If n is even, minus 1 power of 2, that is positive 1, 1 minus 1 0, something into 0 0. So substitute bn value when n is odd. Okay. Substitute bn value is this one. So f of x sigma n is equal to 1 3 5 infinity. Bn value this one, 4 by n pi sine nx. 4 by pi take outside as it is, sigma n is equal to 135 1 by n sine nx. Apply limit above, open this, 1 by 1 sine 1x plus 1 by 3 sine 3x plus 1 by 5 sine 5x up to so on. So 4 by pi sine x plus 1 by 3 sine 3x plus 1 by 5 sine 5x. Now next question. Find the value of bn for the function f of x is equal to x in sine series. So sine series means we should find bn value. Bn is 2 by pi integration 0 to pi f of x sine nx. What is f of x? X sine nx. Now apply Bernoulli's rule. X as it is, derivative of x minus 1. Minus formula x is 1. Now sine nx integration minus cos nx by n. Again the integration means minus sine nx by n square. Upper limit minus pi cos n pi by n minus 0 cos n is 0. Minus into minus plus sine n pi by n square minus sine n0 by n square. This one minus pi cos n pi minus 1 power of n by n. This 0 and this 0. Answer will be 2 by pi minus 1. See here, minus 1 and minus 1 power of n. It become minus 1 power of n plus 1 by n. 2 pi cancel. Bn is the answer. Okay. Now last question. Find Fourier cosine series of f of x cos x when limit 0 to pi by 2, 0 when pi by 2 to pi. Okay. Since cosine series is there, we have f of x a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx. First equation. First we will find a naught value. A naught formula 2 by pi integration 0 to pi f of x. What is f of x? How we will write 0 to pi? 0 to pi by 2 f of x dx plus pi by 2 to pi f of x dx. So 0 to pi by 2 limit, what is f of x? Cos x. Pi by 2 to pi function is 0. 0 into something 0. Integration of cos x sin x. Now upper limit minus lower limit, sin pi by 2 minus sin 0. Sine 90 1, sine 0 0. So 1 into 2 2. So a naught value is 2 by pi. Now here an formula is 2 by pi integration 0 to pi f of x cos nx. Here 0 to pi, so I can write as 0 to pi by 2 f of x cos nx dx plus pi by 2 to pi f of x cos nx. So between 0 to pi by 2 f of x cos nx as it is dx plus pi by 2 to pi f of x value is 0. 0 into something 0. Now here these two take inside. So 1 by pi will remain integration 0 to pi by 2. This is 2 cos nx dx. Mark it as second equation. Since 2 cos a cos b, 2 cos a cos b form cos of sum plus cos of difference. So cos nx plus x plus cos n minus 1x into dx. 1 by pi outside as it is, cos x integration sine n plus 1 by n plus 1x, cos n minus 1 integration sine n minus 1x by n minus 1, limit 0 to pi by 2, where n is not equal to 1. Now apply 1 by pi sine n plus 1 pi by n plus 1 plus sine n plus 1 in pi, this one sine n minus 1 into pi by n minus 1. For this upper limit minus lower limit n plus 1 into here 0, here 0, something into 0, sine 0 0, but sine 91. So this one n plus 1 by 2 sine n plus 1 by 2, it become 1 by pi sine n pi by 2 plus pi by 2 by n plus 1 and sine n pi by 2 minus pi by 2. See here n not equal to 1, it means n is even. 1 means odd, so n is even. So here and cos pi by 2 value will be 0. Okay. So this pi by 2 means we have some formula sine a plus or minus b, sine a cos b plus or minus cos a sine b. So 1 by pi, here apply limit, apply this formula here, sine n pi by 2 cos pi by 2 plus cos n pi by 2 cos sine pi by 2 by n plus 1 plus sine a minus b formula, sine a cos b minus cos a sine b, and here sine a cos b plus cos a sine b. So here this value cos 90 0, so something into 0 0, sine 90 is plus cos n pi by 2 sine 91. Okay, as we know cos 90 pi by 2 90 cos 0, so it will be 0, and sine 91 by n plus 1 plus here cos 90 0 minus here see here cos n pi by 2 sine 91 by n minus 1, cos n 1 by pi outside as it is, cos n pi by 2 cos n pi by 2 take outside common, so 1 by n plus 1 minus 1 by n minus 1. Okay, cross multiply n minus 1 1 n minus 1 minus n plus 1 1 n plus 1 by n minus 1 n plus 1. So this n cancel, minus 1 minus 2 by n plus 1 n minus 1 LCM, cross multiply n minus 1 minus of n minus 1, so minus 2 by n minus square minus 1. See here an value will be minus 2 cos n pi by 2 into pi n square minus 1. So first we will find a1 value, put this one, put a1, so 1 by pi integration 0 2 cos x cos 1x, cos 1x into cos x into cos x cos square x, so 1 by pi 2 cos square x, cos square theta 1 plus cos 2x by 2, these two cancel, 1 plus cos 2x. Now upper limit minus lower limit. Integration, first integration of 1x, integration of cos 2x sin 2x by 2, 0 to pi by 2. Apply limit, 1 by pi outside as it is, pi by 2 plus sin 2 into pi by 2 by 2 minus 0 plus sin 2 into 0 by 2. 1 by pi outside as it is, pi by 2 only remain because 2 cancel, sin 180 0, only pi by 2 since it is 0. This pi cancel, 1 by 2. So a1 value will be 1 by 2. Substitute a1, a1, a0, an in first equation. F of x, what is an? 2 by pi plus 1 by 2 cos x plus sigma n is equal to 1 to infinity. Okay, this one an value minus 2 by cos n pi by 2 by pi into n square minus 1 cos nx. So these two cancel, 1 by pi plus 1 by 2 cos x minus 2 by pi. Apply limit, cos 2 is, when n start with n is equal to 2, means cos 2 pi by 2, 2 square minus 1, that is a plus b into a minus b, 2 minus 1 into 2 plus 1, plus cos n is equal to 4, cos 4 pi by 2 cos 4x by 4 minus 1 by 4 plus 1 minus cos 6 pi by 2 by 6 square minus 1 up to so on. So this one as it is plus pi by minus, take outside common, so 2 by pi minus become plus, plus become minus, and minus become plus. Okay, so this is the chapter regarding Fourier half range series. Now before conclude, okay, this is my YouTube channel Explore Maths with Abdul Azim sir. Like, share, comment and subscribe my channel. Okay, that's all.